So hi everyone. So in last class we discussed about self-introduction. Explain your current project and roles and responsibilities and day-to-day activities and what is source and what is target and what is your data volume and daily how much data you receive daily. Okay, and how many tables and columns are in your project and which schema do you follow in your project like a star schema or snowflake schema. Okay, so then good. Any challenges you have faced. Okay, then about two, not only these two, you can write on your own. And what is architecture? Okay, snowflake architecture and about warehouse. Okay, and multi-cluster warehouse and we seen about scale up and scale out. Okay, and vertical scaling and horizontal scaling and how you decide warehouse size for the project and performance tuning and query optimization. Okay, these things. Okay, then now we're going to see about micro partitions. Micro partitions. So how they going to ask questions. So directly they ask like what are the micro partition in the snowflake or how the data going to store in the snowflake. Okay, uh, how the data going to handle by the snowflake in different ways they're going to ask. Okay, how you need to say answer on real time. So here first go with this one. Okay, snowflake automatically divides every table into small units called micro partitions. So every table, okay, it's going to divide into small units. Why we need micro partitions? So we know, right? Okay, when you have 1 lakh records, okay, so you are fetching uh, one record like so select star from table where id equal to 78,000. So what this query going to do, this query going to do scan the 1 lakh records. So but using partitions, so we go it going to do partition like so 1 to 25,000 in one partition and again 25,000 1 to 2 in one more partition and then again 50,000 1 to 75,000 one more partition then again 75,000 1 2 and 1 L records. Okay, 1 L records in one partition. So without partitioning data or in other system we need to we use it to call indexes. So snowflake don't have the indexes. Okay, instead of indexes we have the micro partition. Okay, so they will ask a question. Okay, have you worked with indexes in the snowflake? Indexes. Okay, indexes, have you worked with the indexes? Okay, what you need to say? So snowflake not support for indexes, so instead of indexes we have micro partitions and cluster key. Okay? So they are going to ask, okay, so what are the micro partition in the snowflake and how the data going to store in the snowflake, how the data handled by the snowflake, and have you worked with the indexes? It means directly they indirectly they are asking about micro partitions. Okay, have you worked with the indexes? So no, indexes won't support in the snowflake. Instead of indexes we have micro partitions and cluster key. Okay, so micro partitions and clusters key we have in the snowflake. Okay, so these suppose you have these are things like these are the partitions. You have 1 lakh records. Okay, you are fetching where id called 78,000. Okay, so without indexes or in snowflake without micro partitions and cluster key. Okay, so snowflake having micro partition cluster key. So think these are 1 lakh records and these are 4 partitions we have. Okay, so without uh, micro partitions snowflake going to scan every record 1 lakh records. It will take time and cost. So now we have the partition. So now snowflake going to think it will skip this partition, it will skip this partition and also skip this partition, then directly it going to scan this partition and it going to fetch data from this partition. It is easy, right? Suppose here taking 1 minute, it takes 60 seconds taking. So but we run the query, it going to take only 15 seconds only. Think like it going to take here 60 seconds. 60 seconds. Okay? But here it going to take, okay, only 15 seconds. Okay, and we are saving the cost and we are saving the time, and we can both saving the cost, and in 15 seconds we can get it. Okay, so we are reducing time 60 seconds to 15 seconds. So okay, we can save time and cost both. Okay, these are the micro partitions. Okay, so now this it will go store like this. Okay, different partitions. Okay, so Snowflake automatically divides every table into small units called micropartitions. So each micropartition holds between 50 and 550 to 500 MB megabytes. Okay, 50 to 500 MB. MB means like megabytes of uncompressed data, and the data is stored in a compressed and columnar format. Okay, we have rows, but the data is stored in columnar format within each micropartition. So Snowflake keeps some metadata about each micropartition, so including the minimum and the maximum values of each column, including the minimum and maximum values of each column. And when you run a query with a where class, Snowflake uses this metadata skip micropartitions that cannot contain your data. This is called partitioning pruning or query pruning. Okay? So query pruning, and it is the main reason Snowflake queries can be very fast, even a billions of records. Okay, so how you need to say in the interview the answer. So the way of telling answer is important. Okay, the way of telling, so answer is important. Okay, so don't join with multiple devices. Join with only single device. Okay, and when they ask a micro partition, so when we insert, when we are loading the data into the Snowflake, so the data going to store in the micro partition in the format of columnar format. So in each micro partition going to store like 50 to 500 MB. The Snowflake going to store also metadata like so what is the row count, and uh, what is the minimum value, maximum value, what are the null values it's going to store. Snowflake knows what is the minimum value, what is the maximum value, and when we run the query, Snowflake it won't scan the unnecessary data, it will scan only relevant data, that we can call like query pruning. Okay, so it will everything handled by the by default Snowflake only. So like this you need to explain. Okay, so don't by heart on, just understand. And also it is a compressor format. Okay, here you can see each micropartition holds between 50 to 500 MB of uncompressed data. Okay, and the data is stored in a compressed columnar format within each micropartition. It means, so in field it is uncompressed data in field, but in the columnar format within each micropartition like compressed. So the data is stored in the compressed format, but in field uncompressed format. Okay, don't confuse. Okay, this and the data is immutable, not mutable. The data going to store like immutable. If immutable, we can't access the historical data, can access the, so historical data it is like immutable data. Immutable means no, right? When we update, suppose I have 100, I am updating the data. If it is mutable, okay, it's going to change and it's going to replace with 200. But if it is immutable, okay, it's going to store old data and also and a new record to both. Okay, this is mutable and immutable. Okay, so finally how to say answer in the Snowflake. So when we insert data into the Snowflake, the data going to store in the micropartition in the format of column format. In each field we're going to have 50 to 500 MB megabytes, and 50 to 500 MB uncompressed data. The Snowflake going to store metadata for each partition like minimum and maximum value and row count, null values. So Snowflake knows what is the minimum value and the maximum value. When we run the query, so it won't scan the all data. It will skip the unnecessary data. It will scan only relevant data. That is, we can call like query pruning and also partition pruning. And by everything handled by the only Snowflake. Okay, so when we insert new data, again this partition going to rearrange by the only Snowflake. Okay, so this is what I'm telling the answer. Okay, when they ask about micro partitions. Okay, remember. Okay, next. Okay, and what is cluster key and when to use it. Okay, so I have table with uh, one.
Madhu, like when we are doing querying, right? For example, any where condition, there
Yeah.
might be many conditions, right? It is not like, as you said, the data will be saved in the metadata. For example, row count and total number of records or maximum min values. These are not only 4 to 5 options, right? In the metadata, it can be having, for example, we need this patient whose name is this and a particular ID. I mean, when we put these conditions, even these kind of conditions will be it won't be possible to store in metadata, correct?
Oh, it only values. Okay. So what are the minimum and maximum values? Numbers, right?
Huh.
So those it going to store in the one of the metadata.
Okay, for example, we have a condition to fetch one particular patient details from this particular region wise and region wise and patient. Okay, so in that particular condition, how it fetches here, micro partition will come into picture, no?
Yes, yes. Yes, yes. Micro partition come into the picture. Yes, yes.
Then
So
what kind of metadata will be saved?
so metadata is like we have like table name, column names, so data types. Okay, who created the table? So when what is created? What is the file size and query history? Okay,
Okay.
suppose
Eh,
so like that. It going to store. Okay, this
Okay.
every.
Assume like there are 1,000 records. So
Okay.
1 to 250 in one partition and 251 to another 500 in one partition. Likewise, there are 4 partitions. So
Yeah.
how, for an example, if an user puts a condition like he needs patient equal to ABC and from this region, America region. Okay.
Uh,
So how in the back end it fetches from assume like it is 251 patient number. Okay. 251 patient number. So it comes in the second partition. It lies in the second partition. How in the back end it fetches from the second partition itself?
so first, usually we have three layers, right? One is a storage layer. So layer. Okay, and cloud services layer. Okay, cloud service. We have three layers in the store. So when we run the query, like you said, where ID equal to, so you said think like any.
251. Something like 251. I'm just
Okay,
giving
two
an
fifty one. We
example.
have the four part. We have four partition. So one,
Right.
two, and three, and four. So it's going to be in this. The 251 will going to stay in this way. Think like that. Okay. So Snowflake, what will do first? When we run the query, the cloud services layer. Okay, it going to check. So who is running the query? Okay, user, and so can you have the access or not? Okay, RBA role based access control. You have the access or not? It's going to check. So if he have the access, then it will check where ID equal to 51. Okay, it hold the metadata, right? So authentication services, metadata, optimization, everything in the cloud services like, right? Okay, so first it will take, okay, where ID equal to 51. Okay, we know. So it's going to store, okay, here 1 to 250. Okay, and here 251 to 500.
500.
Yeah, again, some, okay, 5012, again 7. Again here, 751 to, so 1000. Okay, so what it will do, where ID equal to 251. So it knows, Snowflake knows, okay, where ID is 251 metadata. See, it's already done the partitions. Okay, it's not going to scan because of we don't have the 251. Directly it's going to this partition. Okay, second partition. Suppose you have any and condition, you have some more details, and it will fetch. So exactly those data. Directly it won't fetch. It will first thing. Okay, second partition. So these partitions, the clouds are it going to share with this compute layer. The compute layer. So compute layer it won't scan these or these. Okay, already cloud service will check the where ID equal to 251. Okay, Then this partition it is going to share with the compute layer. Then compute layer is going to compute where id equal to 51 every data. Then it give suggestion to storage. So we have data in the storage layer, right? So directly it's going to print like where id equal to 51. Okay, so what is the data like name, patient name, everything it's going to print. So we can see the result set like this. It's going to work when run the query. Okay, clear?
Right. Yeah, sure.
That is it. So then cluster key. Okay, what is a cluster key, right? Okay, so cluster key. So first, okay, so I have a table like I have table. Okay, so in the table I have 1 lakh records. Okay, in the table I have 1 lakh records. So 1 lakh records means okay. Okay, then we don't apply cluster here. We do not apply. We do not apply cluster key when we have the 1 lakh records. Okay, by default Snowflake has 1 lakh records. Even we have so like okay, so 1 million records. Okay, so 10 million records. Okay, 10 million records. Okay, so no need to apply cluster key. No need to apply. Okay, so when we have large data, when we have large data like billion records. Okay, like billion records. And so in that when we have we need to have the billion records. And so suppose we have any column like city or any date column, we have date column in that table. So when we are writing the queries, these date column, so we are using many times. Okay, where date, okay, and the start date and end date we are using many times. So this date column, so in that scenario when we have large data like billion records, and we when we are using one any column repeatedly in the query, so on that column we need to apply the cluster key. So on that column we need to apply the cluster key. Okay, remember this point. And what are the limit to apply the cluster key? Suppose I have so 10 columns in the table. Okay, so can I apply the cluster key on 10 column? Yes, you can apply. You can apply, but here there is no use if you apply it on all columns. Okay, so there is no limit, no limit, no limit to apply the cluster key. Okay, so if you apply the cluster key on 10 columns, okay, so we cost, but no useful, no useful. Okay, no useful. Okay, you need to pay, but there is no use. Okay, you can apply on one column. So and goes two columns, that's fine. Go with three columns, that is fine, good. Only so maximum up to three columns only. On the three columns we need to have the cluster key as per the requirement. So if there is a requirement, we need to apply only three columns. Okay. So if there is no requirement, we no need to apply. So we can go with one class, one on the one column or two columns. If required, go with three columns. Okay. But don't go more than three. Okay, more than three, don't go. There is no use. If you apply cluster key and more than three columns, there is no use. But there is no use, and still we need to pay for that. Okay, in real time we apply on cluster key only on so one two maximum only three columns. So they going to ask the interview. But actually if they ask what is the limit to apply the cluster on the how many columns we can apply the cluster key, so there is no limit to apply the cluster key. And you need to say so in real time maximum we can apply on three columns only. Okay, there is no limit to apply the cluster key, we can apply on many columns. But maximum we can apply only three columns, that is the best thing. If you apply more than three, there is no use. Okay, there is no use. Okay, so I will give some data. I have 100, 200 and 300 example, and again 200, 300, and again 100. Again I have 300, again 100, and again 200. Okay, so this is before applying the cluster, before applying the cluster key. But after applying the cluster, how will the data going to be after applying the cluster key? Okay, so we have it going to store like so 100, okay, 200 and 300, again 100, 200 and 300, again 100, 200. So this is going to happen. It's going to create partitions like this. So before applying the cluster key, it's going to be like this. So that is not okay. Here 100, here 100, and here 100, 200, 200, 300, 300. Okay, this is not in the proper way. So after applying the cluster key, you can see that it's going to arrange in the proper way. In the proper way. This is okay. After applying the cluster key, this is before. This is after. Okay. So this is okay. When they ask about cluster key, so when we have a large table, so we are running many column repeated queries. So in that second, we need to apply the cluster key. Okay. So here you can check with this thing. So a cluster key is in a column. A, a cluster key is a column or cluster key is a column or a set of columns that you define on a table to tell Snowflake how to physically organize the partition. So we are giving organize the partition. So these column details like that. So by default, Snowflake partitions data in ingestion order. So if your query is always filter on a specific column, okay. See, always filter on a specific column like visit date or patient state, but the data is not naturally ordered by the column, and then many micro partitions will be scanned unnecessarily. Okay, so here see, so when we run the query, it's going to scan everything. Okay, this one, suppose I'm finding 100, it's going to scan this one and this one, but here it's going to scan only this one. Okay, only so this column only. Okay, think like that. Okay, so it scan unnecessarily, will be scan on micro partitions, then many micro will be scanned unnecessarily, and by setting a cluster key on a visit date, Snowflake reorganize the micro partitions. Okay, so that the rows with the same visit date are co-located. So this dramatically reduces the number of partitions scanned. Okay, so in our project we use cluster key on our large fact tables. So we cluster fact patient visit on visit date and provider ID. So because most of our reports filter and date range and date. So when the doctor visited, when the patient joined, and when he discharged. So when insurance claim, okay, those things we have in the healthcare data migration project, right? Those things we're going to discuss by the done. Okay, those only we're going to get like business logic requirement. Okay, because the most of our reports filter and date ranges. Okay, remember, okay, these things when we apply the cluster key. So maximum, there is no limit, maximum we can apply on only three columns. So large table having need to have the billions of records, and the column need to repeatedly we need to use in the query. So in that scenario, we need to apply the cluster key. It going to rearrange the partitions. This thing, remember this thing about cluster key. Okay. So when they ask about indexes, Snowflake not support for the indexes. So instead of indexes, we have micro partitions and a cluster key. So Unitex list these things. Okay. So next, go with next question. What are caches in Snowflake? Okay. So usually we have metadata cache and result cache and local list cache. Okay. So they going to ask about what are the types of caches. Okay. So listen question. Okay. So don't say always something. Okay. First listen the question, understand. Okay, if they ask what are the types of catches in the Snowflake, so there are three types of catches like result catch, metadata catch, local list catch. Okay, or warehouse catch. Tell like that. Okay. Your loan. So tell like that. Okay. So but don't explain until they ask. Wait. Okay. So we need to maintain the. We need to the 30 minutes or 45 minutes we have, right, interview time. So we need to maintain. Okay. We need to suppose if you go with if you like if you want to answer quick, suppose directly. If you answer like fast, they're going to ask one more question. They're going to think they need to ask. They're going to plan ask only 10 questions. So if you give a quick answer, they're going to ask 20 questions. Okay. So don't give answer quick. Okay. Go slow. Don't go fast. Go slow. Okay. If you go slow, okay, it's going to convert to cover 10 questions. Okay. If there is no if you go fast, they're going to ask many questions. Okay. So if they ask the question types of catches, just tell about metadata catch, result catch, and local catch. So if they ask about explain about them, then go with okay. So first go with the result catch. Okay, suppose you are running one query in the Snowflake. Okay, so one second. So you are running one query in the Snowflake. Okay, so it's going to have it's going to give the result. some output result. So after some time, you are running the same query. Okay, so first when you run the query, it going to scan the table. It going to scan the table and it going to give the result. Okay, result. So after some time again you are running the same query, it won't scan this table. So it will give from the result cache. So first time you have run the query, right? So it going to store uh, result cache, store in the result, that result. Okay, so directly it won't scan the table, directly it going to give from the result cache. So up to 24 hours, suppose you have run query today 5 o'clock, today 5 p.m. So until tomorrow 4:59 p.m. up to you can access that result cache, you can access that result cache. But if anything changes in the data, if any new data arrival or any columns are changed, then it going to scan again. If there is no changes, okay, it will until 24 hours it going to give from the only result cache only. First time when you run the query, it going to scan the table, it going to store in the result cache. Second time you run, it give the from the result cache. If third fourth time also, even result cache up to 24 hours. If after query, if any changes happen, but again it going to scan the table. Okay, before 24 hours, if any change happen in the data or any columns, then if you change the query, a query format, okay, if you change filter condition, it's going to scan again. Okay, remember this part, that is up to 24 hours. That is the so result cache. Okay, and metadata cache stores in the cloud services layer. So contains table statics and partition metadata. Suppose you have minimum value and maximum value. So I'm coding like select maximum salary from the table name. Okay, so already Snowflake knows because of it going to store like in metadata, like what is the maximum minimum value. Then directly from the metadata, it going to give you maximum value. Okay, this one. Suppose the data is changed. So by default, when we insert new data, so even again it going to store. Okay, it going to check the data. So again, is there any from the new data any maximum value or any minimum value? It going to check, it going to check. So like that, if you query again, if it's a new data again, so already the Snowflake knows when you are inserting the new data, the Snowflake knows. Okay, okay, you are inserting new data, and in that, if any minimum value maximum value, it's going to store like metadata those minimum and maximum values. So not only minimum and maximum, like row count, how many nulls. So like it going to store row count, how many nulls. Okay, these things done in the so metadata cache. Okay, that is stored in the cloud services layer. So contains tables, statics, and partition metadata. So this is also in the cloud services layer. So they're going to ask what are the types of caches, and each cache where it going to store. It going to ask like, okay. So and again they're going to ask, okay, so they're going to ask about local disk cache in class. So they're going to ask about a local disk cache. So leaves inside the virtual warehouse. Okay, when a query reads the data from the S3 and it catches it on the warehouse SSD, and the next query on the same data reads from the faster local disk instead of S3. So we have data in the state, right? In the stages. Okay, in the stages we have data. When we have data in the stages, we can we can select and we can see the data, right? So first time when you are running the query, it's going to when query reads from the S3, so it catches, okay, it's going to store in the warehouse SSD. Okay, the memory SSD. So when you run the same query again, it won't to scan from S3, it's going to scan from the local disk. So instead of S3 on the warehouse only. Okay, remember. So when you have data in S3 bucket, when we run the query on the stage, okay, we have stage, right? So it's not going to, or it first time it's going to read the data from S3 bucket only. Okay. So second time you run, it will read from the local disk capture, warehouse capture. Okay, not from the. Okay, second time if run, it's going to store from the local disk cache. So what when you suspend the warehouse, it's going to remove from the warehouse. Okay, by default, if you suspend the warehouse or okay, until whenever the warehouse is active, it's going to work. Suppose if by default, if anything happen, like if warehouse or suspended, if you are using any other warehouse, then it going to disable from the warehouse cache. But this metadata cache, no cost, result cache no cost, but a local list cache it going to take the cost. Okay, no cost, no cost, free of cost. Okay, no cost metadata cache, no cost result cache. But for local list cache, it go to, we need to pay for that local list cache. So clear, right? These three caches. So any issue, any doubt? So three, how many this? First they will ask types of caches, and next they will ask explainable caches, and third one they ask so which cache stores in which layer. So metadata cache, cloud service layer, result cache, cloud service layer, localist cache, and in the warehouse SSD. Okay, so tell like that. Okay, these are three types. So this is also so important. Okay, read about these caches. So let's move to, so how do identify and debug slow running queries? Okay, slow running queries. How you going to debug these queries? So we have, right, query profile we have, right? Okay, so how do you identify the debugger slow running queries? Means first what we check, whenever the query is running slow, we need to open the query profile. Okay, so we can find query profile in the Snowflake user interface. Then we go with query history. Okay, so it going to show everything, a visual execution plan for each query. We also have the query ID and everything for each query. Okay, so open the query history, and so see first, okay, what is the suppose I were in the one query, it's taking what is the data it's scanned. It's going to scan 10 MB data, 5 MB data, 20 MB data. So depends. Okay, so first we need to check the, so how much data it's scanned, means how many partitions it's scanned. Okay, so I check partition is pruning happened. Okay, so I check if partition is pruning happened. Okay, in that query we can find, so it is going in the with the partitions with the query pruning or not. It means query pruning means, so it's avoiding the unnecessary data, and or it going to scan everything. We need to check it's taking the query pruning or not. So ideally the partition scan should be a small fraction of the total partitions. Okay, I look for spill warning icons which tell the memory was executed. So I check for the contestant products are missing chain conditions, and I also look at the operator statics if any operator took 8% of the time. So I focus optimization there. For example, in one case, I found a query was scanning 4,000 micro partitions because a cluster key was missing and the date column. And after adding the cluster key, it is adopted 200. Okay, so how we need to tell? Okay, these are the starting. Okay, and the ending is okay. In between, you have different words, right? Different. Okay, you need to say. So first we need to check the query. Okay, so avoiding like where like star, remove the star. Okay, if you put the star, it going to scan the entire table. And if there is any join, check the join condition. Okay, left to right, cross check the join condition. And so what you have use metalize, we have used metalize views. Okay, so first check the query, if anything in the query, then after that go with the query profile and the query history. You can write, first see the, so the query how many partitions it scanned. Okay, so check the table definition, are cluster keys applied or not on the table. So in a chain condition is we applied any wrongly. Okay, so check the scanning time, and how much, what is the MB of scan, how many partitions, uh, how many micro partitions scanned. Okay, check everything. So if the cluster key is not applied, apply the cluster key. If anything in the query join conditions, then so go with the join condition. Okay, I'm checking this is from the query side. So after what we need to say, and the query is running slow, so we need to increase the warehouse size, scale up. Okay, or adding the clusters. Okay, check, so how many users are working at a time. If the multiples are working, it's going to take the delay. And if the warehouse is small, and it's going to take longer time. Okay, so go with the vertical scaling and also horizontal scaling. Okay, go with scale up and go with scale out. Okay, increasing the warehouse size and increasing the warehouse size and adding the clusters. So after this, you need to tell about those things because of this is a basic thing. Okay, query profile and query history. So first we need to explain about these things, and after that we need to explain about vertical scaling and horizontal scaling. Okay, Snowflake concept. Snowflake concept. Okay, so about warehouse. Okay, warehouse and vertical scaling and horizontal scaling. So that is if they go with like that. Okay, okay, you have knowledge like that. I think. Okay, so remember query history. How many parcels scanned? What is MB? Chain condition, filtering condition, and warehouse, vertical scaling, and horizontal scaling. Okay, go remember these factors. So go with those answers. Okay, when they ask about the query. Okay, so then what is data loading? Okay, stages, garbage log. Okay, so region with the same link. Okay, so region same link. I'm ending the meeting, and now only region with the same link. Okay,